Hello, and welcome to this week of Roper Mountain Science Center's Thoughtful Thursday series. Today's topic is called Ready, Set, Wow. You're joining Roper Mountain STEM specialists Val Mosier and Aaron Udaly, conducting some cool experiments and highlighting reactions with gases that are all around us. We'll explore bubbles, fire, and more. You are breathing out carbon dioxide right now, but do you know how this gas behaves? We will show you how frozen carbon dioxide behaves in water, in a balloon, and in surprising settings. For example, can carbon dioxide leak? We will challenge carbon dioxide to put out some fiery situations and answer any burning questions you come up with along the way. Enjoy the show.
Hi everybody, welcome to Ready, Set, Wow, and today we're going to be doing a lot of cool experiments. Some of these are our favorite experiments. My name is Val Mosier, I'm one of the STEM specialists here, and I am here with...
I am Aaron Udaly, I'm also one of the STEM specialists here. And today we're going to talk about something super interesting. We're going to talk about something called carbon dioxide. And before we get into that, I wanted to start us off by talking about just regular ice, like you have in your freezer. You've seen it before. It's just water that is a solid. And when you warm it up, like I'm warming it up with my hands, it's turning into a liquid, it is melting. So that's how ice behaves, just regular ice. But now, Val's about to tell us about something different.
All right, so that is regular ice, which is made of water, and I have a different type of ice here. This is called dry ice, and dry ice is not made of water. It is made from something a little different. As you can see, a couple of little safety tips. Many of you have used dry ice before, probably. Just some reminders, never ever touch it with your bare hands. Do not put it directly on your skin, and never put it in your mouth. We're gonna come back to that. You may hear a second one, just gonna warn you. All right, so dry ice. Woo, there we go. All right, we're gonna think about what might have happened there to our little film canisters. All right, back to dry ice. So dry ice is a solid, so it's something that has been frozen. It's actually made of a gas that's been frozen. Some of you may know what that gas is. If you think you know, kind of make a prediction in your head of what you think it might be. You can see we have a little condensation. There's some water in the room and it's kind of condensing on the cool gas that's coming off of here. And our dry ice goes directly from a solid to a gas. That's called sublimation. Now, we haven't figured out what this is yet. It's not water, it's actually carbon dioxide. So hopefully that's familiar to you. But if it's not, everybody breathe in. You breathe in oxygen, everybody breathe out. You breathe out carbon dioxide. And that's what this is. It's frozen carbon dioxide, minus 110 degrees Fahrenheit. So super cold, 110 degrees Fahrenheit below zero. Now it's called dry ice because if I leave it here on the table in a few hours, there will be no liquid left behind. That's because this is made from a gas. So there's no liquid, it's only going to be a gas. A little different than the ice that Aaron showed us, because if we left that on the table, there'd be a puddle of water or H2O left behind. In case I haven't said it, carbon dioxide is CO2. That's how we refer to it. Now, just to show you for sure that we have that gas and it's coming off of our dry ice. I'm gonna take a little bit of some dry ice pieces and I'm gonna put in it's just some food coloring in there. And as you guys can see sort of the vapor coming off, and notice it's kind of falling. So again, what you're seeing, it's kind of like a cloud. That's some water vapor in the air that's condensing on that gas. And now my balloon is filling, okay? And what kind of gas do you think our balloon is filling with? Do you remember what our dry ice is made of? If you guys said carbon dioxide gas, then you're right. So we are filling the balloon with carbon dioxide gas. All right, now I'm gonna take this off of there. Now, gases take up a lot of space, a lot more space than solids or liquids, hundreds of times more space, which is also what happened with our film canister. I put a little piece of dry ice in here, I put the lid on, and then I let it go. And what happened is our dry ice went from a solid to a gas, it expanded in there. It had no place to go since I had it sealed with my cap, and eventually that was our pop. Now, Erin's gonna show us a different way to kind of collect our gas and trap it in something cool.
I am. So I'm about to show you our leaky faucet demonstration. Before I do that, I forgot to mention at the beginning, Val reminded me when you talked about safety, that we are keeping social distance today, even though we are at the same place, and if we do need to get close, we have our masks ready to go. Okay, so this is our leaky faucet, and in this cup, I have little tiny pieces of the dry ice, and in that container, I've got some water. So it's just like a water container from a cooler. I'm gonna drop these in, and you'll notice they're bubbling just like they did in the other demonstration. And so they're turning right into a gas. And that gas, if we let it bubble, it's gonna rise up to here and then it's gonna kind of fall out. Now, we're not just gonna let it fall out there though. In this cup, up here on this mug, I've got some detergent solution, like Dawn dish soap and some water. I'm gonna put some of that into this mug. I've already got some, I'm just gonna get a little tiny bit more. And we're kind of making like a bubble solution that you would make at your house to like, blow bubbles. So we've got our gas coming off here, and remember that gas is coming from the dry ice. So that is carbon dioxide gas. I'm gonna block its path here, and that's gonna force it to come up this tube and come out of the top. Before it gets there, I'm gonna try to give it a little film up here, which may not have quite enough. Oh, there we go. Okay, so if you look, this is why we call it the leaky faucet. Notice that we've got a bubble. The bubble mixture is a liquid. It's filling up with that carbon dioxide gas, which, as Val mentioned earlier, is sort of heavier than the normal air that we're breathing, and so it kind of falls down when it gets full enough. So we call that our leaky faucet. We've got a gas inside of a liquid with that one. And there's some more cool things about carbon dioxide, specifically carbon dioxide, and we're gonna lead up to some fiery science.
We're about to move on to some fiery science, but before we do, just a little safety thing. We're gonna have a fire extinguisher nearby, and fire extinguishers are actually really connected to what we're doing today because fire extinguishers have carbon dioxide gas in them. So carbon dioxide gas is something that helps us put out the fire. Now, let's think about what we may need though to make a fire. One of the things we're gonna need is we're gonna need a source of heat. In this case, I'm gonna light my candle, and that's going to be my source of heat. We're also gonna need a source of fuel. And in this case, the fuel is going to be my lycopodium powder, which is a powder made from vegetation like moss, and it's been kind of dried. So it's a very fine powder. So it was a solid that we've kind of crushed up. And I'm gonna put that through the heat, but I need one other thing to complete this kind of combustion reaction that makes up our fire triangle. So we have heat, and we have fuel, and we have oxygen. So heat, fuel, and oxygen make up our fire triangle. All right, let's see if we have all three and see what happens when we put all three together. Here we go. Woo! All right, let's try that again. I was hoping for like a slightly bigger one. Let's give it a try. Ooh, one more. There we go, nice. All right, so you guys could see we had a bit of a reaction as we burned our fuel through the heat, through our heat source here, and we used some oxygen coming from the air to complete our reaction. Now, if any one of those is missing, we can't have a fire or a combustion reaction. Interestingly enough, when we burn something, we actually make carbon dioxide and water as the products from our reaction too. Erin is going to tell us a little bit more about kind of another way to look at the same process.
Yeah, so I've got two different flasks here, and I'm about to do a reaction in each one. So in this one, I'm gonna go ahead and put some baking soda. This is a reaction you've likely done before, maybe at school, maybe at home. I'm gonna put some baking soda in here, and then the other thing I'm gonna add is vinegar. So I've got vinegar that I poured out earlier. And I'm gonna combine these together in this flask. So think about what you think is gonna happen when we put the vinegar in with the baking soda. What do you think you're gonna see? Think about it in your head. Let's see if you're right. All right, so we got some bubbles. So if you thought it was gonna bubble, you were correct. And then over here, I'm gonna do something a little bit different. I've got yeast. Yeast is what you would use if you were gonna make some bread at your home. I'm gonna pour it into here. And the other thing I'm gonna put into this flask is right here. This is some hydrogen peroxide, which you may also have at your house. Let's watch and see this reaction. And each of these reactions is making bubbles. So they're both making gases, but they're making different gases. This one made carbon dioxide, which is the one we've been talking about today. And this one is making oxygen gas. So oxygen, if you remember, was part of our fire triangle that Val just talked about. So I'm about to take this little piece of wood, I'm gonna light it on fire with our candle, and then we're gonna see what happens if I very, very slowly put it into this flask, which has the carbon dioxide in it. You'll notice it went out. I'm gonna do that one more time, just in case you thought I was just being shaky. So I'm gonna go really, really, really slow, put it in there, and it went out. Now, look what happens if I put it back in the oxygen one. Notice that the oxygen caused it to flame again, like it caused the fire to get more intense. So basically we can relight the match there, and if I put it over here, the carbon dioxide will put it back out. So that's why this is in fire extinguishers, and obviously not oxygen, because oxygen is going to encourage burning. All right, speaking of burning, we've got another cool fire reaction.
All right, just a little qualification on this one. This may not work the first time. We may not have to do a second trial. What we're about to do right now, please do not try this at home. We are going to attempt to burn magnesium. Now, magnesium by itself will burn in the air. So we could take a small strip of it, which I will do, and we could heat it up. And it's gonna burn fairly brightly, and when the magnesium's all used up, it will stop, okay? And there we go, okay? Now, what I'd like to do though, we know we need three things to make that work. We need our fuel, which is our magnesium. We need oxygen from the air, and we need our source of heat, which is our torch here. Now this time, I wanna attempt to burn magnesium in carbon dioxide. Now you guys have already seen that carbon dioxide puts out a fire, right? Because it displaces the oxygen in our reaction. Typically, like when we do something in gases in the air. Now, what I'm gonna do is I'm gonna put a few pieces. I have a little well right here in my dry ice, okay, which is frozen carbon dioxide. And I have a piece of magnesium, which I've kind of twisted up, and I'm gonna place it in here. Now, what I'm gonna do is I'm gonna light it on fire. Now, I'm gonna take another piece of dry ice and I'm gonna lay it on top. Now, this is carbon dioxide, right? The gas is coming off. It should put our fire out. So, let's see what happens. Get everything ready here, so we can do it all at once. Okay, here we go. Yay! All right, so it eventually the fire stopped, but it's not because of the dry ice. That dry ice didn't put the fire out. What happened was we burned all of our fuel. We were actually getting our oxygen, not from the air this time, but from somewhere else. We were actually getting our oxygen from the dry ice. Dry ice is CO2, 1 carbon and 2 oxygen molecules, and or atoms, sorry. And what we've done is we have burned it, and we have created magnesium oxide and carbon. That black stuff that you see, that's the carbon left behind. We've stripped the oxygen away from the carbon in the carbon dioxide or our dry ice, and that was our source of oxygen. So you could see it like sparked and flamed even more once we put the dry ice on top, because it was just pulling oxygen from our dry ice, making that fire go even faster until all our fuel was burned and all those reactants were gone. So that one worked well. Yay!
Awesome.
Okay,
Yes.
good. We made it. First try. All right. So thanks for being with us today. Hopefully you guys had a lot of fun with carbon dioxide, and
Join us again next time. It was awesome. Thank you for being here.
Great. Bye, guys.